Okay. Hi, this is Keith Bryant for Global SMT and Packaging at SMTAI 2021, and I'm here with Joel on the Koh Young stand in front of their beautiful new Neptune product. I know a little bit about it, but I'm going to hand over to the experts so they can talk about it, and Andy's actually going to give you a run through of how the system works. So, Joe, over to you.
All righty. Well, thank you for being here, first and foremost. We're very excited about this product. This is our next offering in the 3D inspection world that we're so notably known for. We did a lot of market research to try to understand where the shortfall was in this particular space, and that's pretty typical of Koh Young, right? Voice of the customer. We noticed that there was a need for the ability to do conformal coating inspection and other dispensed process inspections at production rates. There's equipment out there today that can do that, but it's very slow. And so we needed to differentiate by applying a new technology, which is known as lift, and I'll talk a little bit about how we adapt that. But again, this system is designed for dispensed process. That can be conformal coating, can be underfill, epoxy, all kinds of, again, fluidic materials where we're looking at not only area coverage, but also volume, height, and that's really the key. So it's a combination of 2D and 3D, right? For 2D, we're obviously applying the UV technology, and Andy's going to walk through some of that from a conformal coating perspective here in just a minute. For 3D, we're using something called, as I said, lift, or our adaptation of lift. Lift stands for laser interferometry for fluid tomography. And basically what that is, it's low coherence IR or near IR. And we're basically firing a laser through a mirror using the angle of incidence equals angle of reflection concept. From that, we can gather multiple layers of fluidic structure. This is raw data, and then we use that to build our model to take our measurements from. So again, I mentioned the fact that speed was really the issue when it comes to conformal coating inspection, because the systems that are out there today, although they could do 2D fairly well, that height measurement, that thickness measurement was really a shortfall in the market. And the reason was nobody was able to do it at a fast enough rate. Yeah. Based on production needs, right? So the lift technology is approximately 250 times faster than the I'm not even going to begin to say it. The other technology that's being used out there, right? The old stuff, exactly. So again, yeah, that's in a nutshell what the system's all about, and what we plan to do with it. We have some very exciting projects going on right now with one of our key customers on various fronts: underfill, conformal coating, epoxy. So we hope to learn and leverage from that, and I think you're going to see a lot from us with this tool in 2022 and beyond.
Oh, yeah. I have to say it sounds pretty exciting, and it's definitely filling a gap and a need in the market that's been there for a long time, and it started to grow a lot more because with lead-free soldering, more people are going back to conformal coating with all of the low standoff height components. Everybody's looking at underfill, and it sounds like you guys are pretty much filling a big open space.
Right product, right time, right? Yeah, and we're set up to handle all of the various materials that are out there in the conformal coating world, the silicons, the acrylics, and so on and so forth. So again, let me turn it over to Andy, and let him show you a little bit more about exactly how we're doing that from a conformal coating perspective, and see what that can show you, right?
So we'll just run through a little the inspection conditions that we have for everything. So we've got the 2D inspection condition, looking for coverage, looking for splash, looking for bubbles on the component. And then we have the thickness, right? That's where the technology comes in for the 3D height on the leads of a component, on the shoulder, the leads. If you just kind of look at those. So for here, we're looking at a spot on the board. So you put different locations on the board so you can measure the thickness of that area to make sure you've got uniform coating throughout the whole board. So here you can see a 3D image of where that coating is, located and within our range. I chose this one because it's failing. It's low. It's out of our spectrum. We can see bubbles on top of a component, right? Set the parameters of where you want it to fail, so we can see all the bubbles on top of the part. Insufficient areas. So we've got holes on here that I didn't ignore, right? You can ignore certain areas that you don't care about. Don't ignore areas you do care about. And so you see insufficient areas using the 2D lighting. And then this area is supposed to have no, right? You can see there's a little splash on the screen, so it's a splash off of the conformal coating spitting out. And then we can go back. And then you can look at a component. So we can take different slices on the leads and the gap between the leads to measure the thickness of that component. Yeah, and this is what we're doing. We're taking 2 slices off of the lead, making sure it's within our spec. And then we're looking at the gap as well.
So you can really drill down into the detail.
Right. And you can do the scan and you can see where that lead is and where the conformal coating is. And that's kind of the basics of kind of all the features and the underfill as well.
And that's basically where we're at today, right? So plans in the works to expand, as needs come about. And again, the technology is set up such that it can adapt, right, to those new needs. So again, this is kind of a starting point with the conformal coating inspection and the underfill, but we see this addressing other needs as well, as you had noted, Keith, with the really the emerging markets, if you will, going forward, electronic vehicle, continuing with the 5G infrastructure and all things cloud-based manufacturing, right? So, yeah, very excited.
Yeah, it's. I have to say, it's doing a lot more than I was expecting to see. So yeah, it's definitely all. I hear what you're saying about new applications and everything else, but it's already a capable system for what you need to be doing.
Very much so, yeah, and that's the key. So we feel like, again, starting with conformal coating, being able to put this in a production environment, giving our customers the opportunity to do true 3D height measurement in certain locations at production speeds is really going to be the differentiator. That's what the market's asking for, and that's what we're delivering. And oh, by the way, I don't know if I mentioned it, but we actually received the Mexico Technology Award for test inspection earlier this morning for this system. And so again, others
Starting at the top.
are recognizing the advancement in technology, and that's always humbling to receive awards like that. Being recognized for being innovative and being at the forefront.
It's a great extension of the technology that people have been using within AOI. Correct. And I can see here even from the basic stuff that let's be honest, the machine does what it says on the tin.
That's exactly right. Yeah, that's right. And that's we want to deliver on what we promise, and again, use that 3D measurement-based technology that we put so much time into developing in other avenues and other places up and down the assembly line. And this is one of those areas where we have a really good fit. And we've got some other things we're working on as well, which you'll hear more about as we go forward.
Oh, I'm sure. I mean, you guys have been technology innovators for a long time, so I'm sure there's more to come.
There is more to come. Be assured.
Okay, well, I look forward to chatting to you next year to hearing more about it. So thank you, Joel. Thank you, Andy.